Hi everyone. So in this video let's discuss about the video processing pipeline in Netflix. So if you don't know about Netflix is basically a video streaming platform where you can watch different type of movies, TV shows, everything. So in this video we'll try to discuss about how does the video processing happens in Netflix. That means whenever any new movie is released, right? A new movie or new TV series is released, then how that content is uploaded to Netflix, and then how Netflix starts different type of processing on that video content and how it delivers that content to the end users. Because if you can see here, Netflix is not a small company, it's a very large company. It has more than 280 million users and it's available on more than 190 countries and it has more than 17,000 content. So how does it manage this content and how does it ensure that the content is delivered across multiple users all around the world, and that too with the minimum latency? So those are the details that we are going to discuss here. So if you talk about different stages of the video processing, so here I have a simple diagram. There are mainly three stages of the video processing. So the first step is the ingest, second is the processing, and the third stage is the distribution. So the first step, the video is uploaded from multiple sources like multiple movie producers or production houses. Those videos are uploaded and then Netflix checks. Once those videos are uploaded, Netflix checks those content, how the content is, and then also it does a basic validation on that, like if the files are valid, if there is any missing file or the files are corrupted or something like that. And once the videos looks good, then it starts the processing, and there are multiple steps: chunking, encoding, assembly, and finally once the processing had been done, video has been processed, then it prepares the video for the distribution so that many users across the world they can view the content. So first let's discuss about the stage 1, which is the ingest. Now I have a simple diagram here. So you can see there are multiple content sources, different production houses or different distribution partners. They upload their content, that is a video, they upload their video on Netflix, and once Netflix has received those videos, the first thing that they do is that they runs those video through the IMF pipeline. So IMF stands for interpolable master format. So whatever the video that is uploaded, the video first goes through this pipeline, and what it does is that, so the video has been uploaded, so this IMF, this extracts the video, it separates out the video, separates out the audio, subtitle, metadata, other things. So suppose the user has uploaded a video which has the which has the visuals, which has the audio, everything. Now this IMF, it separates out those separate parts. So it creates a separate file which has only the video. Okay, it will not have any audio, anything. For the audio, it will create a separate audio file, and for the, it will extract the subtitle and it will create a separate file for the subtitle, and for the metadata it will create separate file. Now you might think that why do you need to do these things? Like user has uploaded a video, and why do you need to extract out the video, audio, everything from that video file? Why don't we just directly store the video file in the server, and whenever the user requests for the video, we'll just serve the video from the server itself? So there is no complexity, right? But the reason why they runs this video through the IMF pipeline and extracts the video, audio, and other details from the video is that, so let's look at this example. Suppose that there is a movie has been released. Okay, now that movie is available in English version, French version, and Spanish. In these three languages the movie is available. Okay. Now if you don't extract the audio, video, and everything from the video, then to serve the video in three languages, what you have to do, you have to have three files. You have to have three separate files for the same movie for three different languages. If you just consider this, there you are wasting a lot of storage spaces, because the visuals are all same in all three languages, but still we have to create three separate file for three different languages. And not just three different languages, if there are more languages needed, then you have to upload a entirely new video file, even if the visuals are same across all the languages. Now how IMF handles is that, now Netflix only stores one video file, that is the video essence, because whatever be the language, the visuals are still the same. Right now, whenever they need to serve the movie in a new language, what they do, they just add the audio file for that specific languages. Okay, so if they want to release the movie in 30 different languages, they only need to upload the 30 different languages audio files. So they do not need to repeatedly upload the video files, because the video are same across many languages. So this way they are saving a lot of storage space. So that is the first benefit. We have another example. Suppose that the movie, you need to do regional versioning for the movie, because different countries might have different laws regarding what can be shown or what cannot be shown. So it might happen that a specific movie might have some visuals or some screen some part which is not allowed in certain countries. Okay, so in to handle this scenario, if you don't use IMF, what you have to do is that, suppose that you need to cut out a 5-second screen for a specific country. Okay, so if you don't use IMF, then your editors will have to edit the movie and re-render and re-upload the entire 2-hour or 3-hour movie file for the specific country. Okay, but since you are using the IMF and you are extracting the video and audio separately, what you can do is that you do not need to re-upload the video. Instead, the metadata file that you have, it can act like a instructional recipe, and Netflix creates a recipe for the US says that play the video from this to this. Okay, in the US the entire movie is allowed, and they can create a second recipe kind of thing, like where the rules are very much strict in some countries. So in that country they can only say, they can mention like, okay, don't play the movie entirely, play the movie up to 45 seconds and then skip 5 seconds, and then after the 5 seconds then 1 second start playing. Okay, so these kind of scenarios you can easily handle because you have already separated out the movie audio and subtitle and metadata. So this is the first step. Okay, now if we just go here, you can see there is another step, that is the inspection and validation. So let's discuss about that. Whenever there is a video is uploaded on Netflix, so before Netflix goes ahead and starts the processing for that video, the first thing that it does, it checks if the video is valid or not. So these are some of the validations it does on the video. Okay, so it checks if the format is validated or not. Okay, and it checks if the audio and the video are both are in sync or not, and they also check if there is any damaged file or damaged frames in that video or not. Okay, and they also check the different color space and frame rate. And the reason they do this, because suppose there is a corrupted video file, okay, and it's a maybe 2-hour video, 2-hour movie, and after 1 hour in the movie some of the screens are blank or audio is not in sync with the video, like that. If you don't validate the video before you start processing on this, then you might start processing and you might end up processing a corrupted video, and once the processing is done, then you see that, okay, the video is not up to the mark, the video was corrupted. Then all the resource power that you have spent regarding processing the video, that resource power is wasted. And hence, to solve this problem, it always checks that the video is valid video and it's a good quality video before it starts the processing, because processing a corrupted video doesn't make any sense, and that's exactly what they are doing here. Now comes the video encoding. So you might think that, okay, the movie producer has uploaded a movie in the 4K version, so we'll just store the 4K version as it is, and whatever the user it is, we'll just serve the 4K version to all the users. That might sound simple, but that doesn't make sense in real world, because in real world, not everyone's internet connection is same, and not everyone's screen size is same, not everyone's device hardware capabilities are same. So Netflix always prepares different formats of the same video so that it can serve the video across multiple users. So if you just consider this scenario, suppose there is a user who is using a 4K TV, okay, and he has very good internet connection as compared, and there is another person who is using his cell phone and who is using mobile data to view the video. If you just compare these two persons, you can see there is a gap in the internet speed. The first person has a very good internet speed and the second person doesn't have a very good internet speed. So we have to make sure that we serve the proper video quality to respective user based on their internet speed, so that their viewing experience is optimal. That's why Netflix does the video encoding. So whenever a video is uploaded, no matter what is the original quality, maybe the original quality of the movie could be 4K or 8K, whatever the user has uploaded, and Netflix does is that it creates separate quality of that same video, creates a 4K version of that video which is suitable for high-end display smart TVs and where internet speed is very high, and then it creates another version of the video which is in the 1080p format that is suitable for laptop, mobile screen, and then for 720p video format for those people who has slower internet connection, right? So this way it creates different version, different quality versions of the same video, so that depending upon the screen size, internet connections, the users can have a optimal video viewing experience. Now regarding the encoding, so they don't do the same encoding for all type of video. So if you just see this diagram here, so before starting the encoding, they check what is the type of video. Okay, so now it could be like, it could be an animated movie, just like Spider-Man Into the Spider-Verse, which has flat colors or sharp edges, and it could be a natural documentary like Our Planet. Those documentaries might have complex texture, constant motion. So depending upon what type of video it is, it will choose what type of encoding at that it needs to do, and then it will start that type of encoding depending upon the video. And why this is important, because you might see that the animated content might achieve excellent quality at 2 mbps, while action movie that needs maybe 5 mbps for the same perceived quality. So depending upon the what type of video it is, they have an algorithm so that decides like what type of encoding that they need to do. It's not that they does the same type of encoding for all type of videos. Instead, they have a mechanism that tells them what type of video it is, and then based on that they does the encoding on that video. Now regarding the video encoding, so they have a service. They are using microservices, by the way, for the entire video processing, and I'll explain later why they are using the microservice for this. So they have given the name of this video processing is VES, that is the video encoding service. They does the stateless processing, and they use containerization here so that across multiple machines the environment is consistent, and they are using auto scaling based on like whenever there is lots of videos are uploaded, so that they can spin up more instances so that video processing can be faster, and as and when there is not that much demand, so that they can reduce the scaling. They have the failure isolation, so if one video chunk is failed by any worker, if any worker fails to process any specific type of video, specific chunk of the video, then any other worker can pick that up. Okay, so here I have a very simple diagram about how does the video processing happens. So we have something called an orchestrator. Whenever there is a new video is uploaded onto the Netflix, this orchestrator, what it does, it checks the video. Suppose it's a movie of 2 hours, and it splits the video. It doesn't start the processing of the video entirely, like it doesn't immediately start the processing of the video. So what it does first, it splits the movie or split the video in multiple chunks. For example, there is a 2 hour long movie, so it has splitted that movie into multiple chunks, maybe 720 pieces of chunk. It has splitted that, and it put that chunks into a queue, and then there are multiple workers are there. Those workers will check the queue, and they will pick some chunks of that video from the queue. So suppose that there is a worker 1, the worker 1 is picking the chunk 1 to chunk 240, and there is a second worker who is picking the chunk from 241 to 480, and this way video processing happens chunk by chunk depending upon different worker. So as and when if the movie is very much large, suppose that it's a 10-hour long movie or 10-hour long video, so then there will be more workers involved, and if it's a long video, maybe 5 minutes, 10 minutes, there will be less number of workers employed, and these workers are EC2 machines, so they can spin up more EC2 machines as and when they want depending upon the video. And this way you can understand, like if you just see here, we are doing the parallel processing here because we have broken down the movie into smaller chunks, and then we are starting the processing for those chunks. This way we are doing the parallel processing so that the movie can be processed much more easily. And these workers, as and when these workers are processing the chunks, it stores the chunk into storage, which is the S3 bucket, and then once the processed chunks has been stored, all the processing of those chunks has been completed, then the orchestrator, what it does is that it checks and it sees that once it checks that okay, all the processing of those chunks has been completed, then from the processed chunks it takes those processed chunk and it assembles them into a final video. Okay, so this is the overall mechanism that they has, how they starts the video processing chunk by chunk. So this is the example that I was talking about. Suppose there is a 2-hour movie and it has created 720 chunks. So for each 10-second chunks, it has created 720 encoding jobs. And now if those jobs takes 2 minutes on a single machine, then sequential processing will take 24 hours, right? But since we are doing the parallel processing, so we can easily complete the video processing in 15 minutes. And this is what the benefit of this chunk based video processing. So we are breaking the video into smaller chunks and then we are doing the processing on them. And if any of the chunks fail, if any of the workers is failed to process the chunk, then the chunk will be sent back to the queue once again, and then any other worker who is available who can pick up that chunk and they can start the processing. Okay, so our video has been processed. Okay, so we have broken down our video and we have started the processing on the chunk. So one thing we have to keep in mind is that we are doing the processing of the video chunk by chunk, and the whole processing that we are doing so that we can serve the video across multiple users around the world. But the one thing we have to remember that there should not be any compromise in the quality of the video. Okay, it's not that suppose that user has uploaded, production house uploaded movie in 4K format. Now you did all the processing and all. Now after processing you are seeing that the video quality has been degraded a lot and the video is not watchable at all, or there is lots of flickering on other issues. So if this kind of thing happen, you have to make sure that this kind of thing shouldn't happen, because if the video quality is not good, then the user who is watching the video will not have a good experience and they will not be happy with the Netflix. So to solve this problem, they have a mechanism called VMAF, that stands for Video Multi-Method Assessment Fusion. So this is like a machine learning model. So what it does is that it checks the original video and it gives it a score. Okay, and then it checks the processed video or encoded video and then it gives us a score, and based on that it compares that how much the quality has been degraded or not. So if we just see here, so what it does is that it works by comparing the original pristine source video frame by frame against the final compressed stream that is sent on your device. Okay, and it compares these two elements and then it measures like how much image detail has been lost in the video processing, or how much important details or visual features has been lost in the video processing. So based on that it just checks to ensure that after the video processing we are not losing too much quality. Okay, so and if we just talk about the VMAF basically it's a Netflix developed this open source framework to predict how humans actually perceive video quality. So they trained it on thousands of hours of subjective quality ratings from real reviewers. So this is kind of a like the whatever the score that the VMAF gives to a video, you can understand, you can assume that how a human will view that video, or how the human will rate that video from their perspective. So this is an indicator of how much quality does the video have, and this is a good indicator to ensure that after video processing we are not losing too much video quality. And it acts as a feedback loop for Netflix pipeline. So they keep an eye on the VMAF score on that video, and they understand, and this way they understand that how their video processing pipeline is working, and if there is any problem in the video processing pipeline, because if there is any problem in the video processing, because if the VMAF score goes down drastically, they can easily understand that there might be some issue with the video processing pipeline. Okay, so this was about the VMAF. So now let's talk about the cloud architecture of the video processing pipeline. So as I was mentioning earlier that Netflix video processing pipeline is entirely on the AWS. So if we just see this diagram here, so as and when user is uploading a video or movie, so they have a S3 bucket which is the source bucket. Okay, so as and when any new video is uploaded, they have some lambda functions. So lambda functions checks and sees that okay, new video has been uploaded on the source bucket, so it breaks down that video and creates multiple jobs and puts those jobs in the SQS job queue here, just like here. And then there are a bunch of EC2 machines, and then there are a bunch of workers who pull the jobs from the job queue, and then it starts processing on those jobs, which are basically the video chunks. As and when the workers are completing the video process, they store the process video chunks into another S3 bucket which is known as the output bucket. So this is how it works. Whenever new video is uploaded, the lambda function breaks down that video into multiple chunks and creates different jobs for that video and puts the jobs in the SQS job queue, and then these workers pull the jobs from the job queue, and then the worker starts processing the job queue or jobs, or basically you can say the chunks, video chunks. And as and when the video has been processed, then it puts the video processed chunks into the S3 bucket. So if you just see here, so the EC2 machines, these works as a video encoder. These are the workers who process the chunked video, and the S3 bucket that we are using for the source files and also for the outputs. And this SQS, this is used for the job queues for work distribution, so that we can distribute the video chunks processing across multiple workers. And we are using the auto scaling here, depending upon how many jobs are there on the job queue, depending upon that we are spinning up different workers. So this is the high level cloud infrastructure for Netflix video processing pipelines. So the reason why they decided to choose cloud for their video processing pipeline is that so there is not any predictive traffic for the video processing. So you don't know like when multiple movies will be released or when new season will be released, right? So when any new season is dropped, then thousands of hours of videos are uploaded in Netflix and those needs to be encoded. But when suppose that there is not much release, not much movie release or new seasons, then the demand drops significantly. So to handle this, they has chosen put their video processing pipeline into the cloud so that they can easily do the auto scaling based on the traffic. Now one important thing is that adaptive bitrate streaming. So Netflix, instead of creating a one large file, what they do is that Netflix creates multiple versions at the different quality level so that the player downloads small segment, typically 2 to 4 seconds video, and can switch the quality between the segments depending upon the network speed. Let me explain what does it mean. Suppose that there is a movie of 2 hours. So it doesn't directly serve the 2-hour movie directly in the API response. Instead what they do, they serve the movie in chunk by chunk, and that's how they store the data as well. So suppose there is a 2-hour long movie, they will not save the directly 2-hour long movie, so they will break it down into a separate chunks. So one chunk could be for 4 seconds. Okay, suppose that these chunks are 4 seconds, so there is one chunk which is of 4 seconds, and that first chunk will be saved in multiple formats so that we can serve the user different videos based on their network speed. Okay, so it will be saved in 4K format, 1080p, 720p, 480p, and then the second chunk, that is the next chunk, that will also be stored in different formats. This pattern is repeat for the entire length of the film. And the reason why this is important, because you just clicked on the view movie, so you are just trying to view that movie. So what happens is that Netflix checks what is the network speed and your device screen size. So once it has got an idea about the network speed and the device screen size, then it will send the chunk, it will decide which quality of chunk you need to view. If your internet speed is good, then you can view the 4K. If your internet speed is a little bit slower, then you can view the 1080p. So like that it goes. Suppose that your internet speed is okay, so then chunk 1 it sent you with the 1080p. Because your internet speed is okay, so you can view the 1080p, so it just load the chunk 1 data, which is the 1080p. Now you are viewing that 4 seconds. Suppose that within that 4 seconds your network speed dropped, something happened, so then it sees, Netflix checks that okay, your internet speed has been dropped. Now it sends you, it doesn't send 1080p anymore for the chunk 2. Instead, for the chunk 2 it sends you the 720p quality, because that's what your internet speed is now. And suppose that suddenly your internet speed has improved, so now you can once again view the 1080p. So this way, on the real time basis, they check what is the internet speed that the user has, and based on that they send the data chunk by chunk, and they check what type of quality it should send in each chunk. I think one real world example I can give that I have myself has seen in YouTube. Suppose that I am viewing some video, so the video quality is very good, and all of a sudden I see that the video quality dropped. So I am viewing maybe in 1080p format, now suddenly it dropped to 480p. Now maybe after a few seconds I can see that the video quality suddenly improved, it once again becomes 1080p. So this is the reason, because as and when your device internet speed is increasing and decreasing, Netflix is checking that, and it is sending you chunk by chunk data, and it also checks the quality that will give the user the optimal viewing experience. So this is what we call this as a adaptive bitrate streaming. Okay, now our video has been uploaded and video has been processed as well. Now the next part is that how do you deliver the video to the end user. Now the video data is pretty much static, right? And we need to serve the video across multiple users across the world. So the first thing that comes into mind, CDN, right? Yes. So Netflix also use CDN so that the latency can be minimum for multiple users across the world. So what Netflix used to do is that earlier Netflix used to use a variety of CDN networks, like there are already bunch of big CDN companies like Akamai, Level 3, Limelight. So Netflix used to use these CDNs to serve the video content across the world. But as their users base were growing, these CDNs were no more enough to handle such a traffic. So what they eventually did, that they created their own CDN, and that's what they give the name is at Open Connect. So they created their own CDN network and they named it as a Open Connect. So the benefit of CDN, you already know that this is the original server, and all across the globe we have multiple edge servers, which is also known as CDNs. And suppose that someone from United States is trying to view some content, so this server is here, so they do not need to connect to the server all the way to here. Instead, they can check what is the closest CDN server that is available near to that user location. They can serve the data from the
It's
CDN
9
itself.
o'clock.
Okay, and obviously the movie content needs to be there in that CDN. Like if the data is not there in the CDN, then they'll eventually have to come to the original server and make the request. But if the data is available in the nearest CDN, then the data will be served from the CDN, and that way the content loads very faster. So the example that I was talking about, suppose you are logging in from the Budapest, right? Instead of connecting to the main server in the United States, it will load a ditto copy of the same content from a CDN server that is closest to the Budapest. This greatly reduces the latency and the time taken between a request and the response, and everything loads really fast. So this is the main point of the CDN, so that user doesn't have to query the main server, original server, which might be far away from the user. Instead, users can connect to the nearest CDN servers and they can fetch the data very quickly, and that reduces the load really a lot. Now I told you, right, Netflix earlier used to use different type of third-party CDN services, right? But I told you, right, but later they created their own CDN. So this is an interesting story. If you see this orange box, this is actually a CDN box that Netflix created. Let me show you. So if you just read this story, so instead of relying on the AWS server, they install their very own around the world, but it has only one purpose: to store the content smartly and deliver to the users. Netflix strikes deals with multiple internet service provider and provides them the red box you saw above at no cost. So what Netflix did, they created this type of red boxes and they delivered these red boxes to multiple ISPs across the world, and they gave it for the free. So ISPs install these along with the servers, and these are basically the Open Connect box. So ISP install this along with the servers, and these Open Connect boxes download the Netflix library for their region from the main servers in the US, and if there are multiple of them, each will rather store content that is more popular in the Netflix region, in a region, to prioritize the speed. So this device is a CDN. So these red boxes, this will act as a CDN, and Netflix gave these boxes to ISPs, and different ISPs install these boxes along with this main servers so that the ISP level caching can be done. So eventually it happened like these boxes acted as a ISP level caching for Netflix content. Now in Netflix there are a bunch of content, right? Now what type of content you want to cache here? Because here you have limited space, right? All across the world, depending upon whatever region that you are in. Suppose that you are in the United States region. So in that United States region, in the CDNs, you will store those movies or those TV series which are very much popular in that nearby area, so that you can have the optimal experience for most of the users. But suppose that someone from the United States tried to watch a movie which is not that much popular, and that's probably not in the CDN. For that movie, it will have to query to the main server and get the data. But for the majority of the movies which are more popular across the regions, we will have the data in the CDN itself, so that most of the users can have the optimal experience. Here it is saying, so a rarely watched film might take some time to load than Stranger Things episode, which is very much popular. Now when you will connect to the Netflix, the closest Open Connect box to you will deliver the content you need. Thus videos load faster than if your Netflix app tried to load it from the main server from the US. Yes, exactly. These orange boxes are all across the world with the ISPs. Now whenever you are trying to view any content, it's directly giving you the content from the CDN itself. And if you are trying to see any movies which is not that much common in that area, then eventually it will have to query that movie from the main server, which might take a little bit more time. But for the majority of users, most of the data, and even Netflix claims that around 90% of the data they serve, 90% of the data that the user views, those data are served from the CDN, which is also known as the Open Connect box. So this is the end game. This is the eventual thing which Netflix has done, and using which they can make sure that most of the users across the world, they can have an optimal viewing experience. So this was the overall architecture diagram for Netflix, from starting from how the videos are uploaded, then how validations and inspections done on the video, and then what type of processing is done on that videos, and eventually how the videos are distributed across the world using CDNs. So here are the key takeaways from today's video regarding Netflix video streaming architecture. So Netflix splits the video into segments so that hundreds of machines can encode simultaneously. So this reduces the processing times from days to hours. So the main thing that they are doing is that they are breaking the video in chunks so that they can enable the parallelism during the video processing. Per content optimization beats one size fits all. So each video, depending upon the what type of video it is, it gets a custom config ladder based on the complexity. Animated content uses less bandwidth than action movies at the same perceived quality. So depending upon the what type of video it is, based on that it customizes the what type of encoding that it needs to do. VMAF measures what humans perceive. So you need to always make sure, keep an eye on that, what the quality that you are maintaining. So Netflix open source their quality metrics before traditional metrics did not predict user satisfaction. Measures what measures to users, not what easy to measure. So you have to make sure that you are doing the scaling, you are doing all those processing, everything is fine, but you should not compromise on the quality on that video processing you are doing. After encoding, the video should be still of the high quality. That's what they are maintaining using the VMAF. And this tool they have also open source. So even if you are also building something, you want to use this tool in your application to measure the video quality as compared to to understand what human perceive as the video quality, you can use this tool. Cloud enable elastic scaling. So the video upload traffic is not fixed, it is dynamic. So to handle this dynamic traffic, they have gone for the cloud. They are using the microservice architecture for the video processing. So video processing has many distinct concerns. Separating them into services makes easier to develop, deploy and scale. Because in a video processing architecture, there are multiple things that they need to do. So they have decided gone for the microservice so that they can easily individually develop, deploy and scale multiple parts. Pre-positioning content reduce latency. OpenConnect places videos in ISP network before the user requests them. The best optimization is avoiding network round trip. So as they are using the OpenConnect boxes for the caching or for the CDN, so they are most of the part they are avoiding the network trip altogether to the main server, because most of the data is being served from the CDN itself. Quality gates catch problems early. So checking quality after each step prevents wasted work. A corrupted source might ingestion saves hours of failed decoding. In fact, the very first step that they are doing is to, before starting the video encoding process, they are checking if the video file matches Netflix standard or not. Because if the video file it's not up to the mark, then encoding this bad video will be a wasted work. So they are checking the quality at the earlier step so that they can prevent the wasted work in the encoding of the bad videos. So I hope this video gave you some idea about how does the Netflix video processing pipeline works. Let me know if you have any questions, and as always, thanks for watching.